do you have any knowledge about the Fibonacci sequence and phi and those type of laws that are in nature?
Yeah, I find the Fibonacci sequence to be really really amazing. And just for our listeners, people typically start it with a one, and then let me just, since I'm doing this, I'll do it my way. Start with a zero, and then you add a one, and so you've got a 0, 1, and then if you just add the two numbers together, that's how the Fibonacci sequence goes. And so 0 plus 1 is 1. And so now we have a 0, 1, 1. 1 plus 1 is 2. And then you take the previous two numbers. 2 plus the 1 is 3. Take the previous two numbers. 3 plus the 2 is 5. Take the previous two numbers. 5 plus 3 is 8. And if you just follow that sequence, you now have the Fibonacci sequence. Okay, so seems plain enough. Well, it turns out that sequence just shows up in surprising places of the world. You talked biology. So if you do counts of a lot of different flowers, then you take the number of petals that they have, they tend to be a Fibonacci number. You'll get 5s and 8s and 13s. And sometimes much larger than that. If you look at a pine cone and you take the number of whatever you call the little things on the pine cone, those tend to be in Fibonacci sequence numbers. And so the Fibonacci sequence shows up in a variety of natural phenomenon like that. It can be shown in reproduction of, I think I've seen it with bees and a lot of organisms. If you just take the numbers that are going to be alive after successive generations, you get Fibonacci numbers. And so it's an interesting thing. It expands though. If you take it's a little harder to describe this just verbally, but right. Take a square, it's 1 by 1 unit, and then you add another 1 by 1, then you're going to be 2 long. And so we're moving from the 1 to the 2, and then that gives you a 3. Okay. And then you stick a 3 on, and you kind of build the successive rectangle by just chaining these rectangles around, and they're going to start to go in a circular way. If you connect an arc from the corners of that rectangle that starts to build in the right way, then it forms what's called the golden spiral. And the golden spiral is the shape of a nautilus shell. So we're thinking about, again, a biological phenomenon. It also can be shown to match the spirals in a phenomenon in outer space, like in galaxies. And so now we've moved from biological to a physics. There's a great leap there from a physics standpoint. And that came from just an abstract concept. And so that's interesting. Now, if you take those rectangles and you look at the ratio of sides, then the limit of those ratio of the sides goes to a special mathematical number called phi that you had mentioned. The limit of a ratio of Fibonacci numbers goes to that particular number. And using that number, it gives what's called the golden rectangle. And that golden rectangle was believed by the Greeks to be the most perfect form of rectangle, and they used it in their architecture a lot. Some people have written about finding the golden rectangle in other phenomena of nature as well. For example, the human body. Now, to be fair, there's some criticism of that literature. Critics would say that these people are looking for a Fibonacci sequence under every bush, so to speak. Yeah. And so there's probably some fair criticism there. But nevertheless, I think you will find that this thing does show up. And so what we have an example of then is one abstract concept, namely the Fibonacci sequence, and how it shows up, as we mentioned, in disparate parts of biology, in physics, and then humans have an affinity for it. So there's a beauty connection there, and are going to use it in architecture